Okay, so this is my video for standard 4.1, which gives us these multi-particle states and asks us to show that they are equivalent and demonstrate the same anti-correlation behavior. So to show they're equivalent, we can just rewrite psi x in the spin z basis. And when we do that, we get that psi x is just minus psi. So since the states only differ by a minus sign, they'll show the same, an observer will record the same anti-correlations regardless if the integral state was prepared in the first or second state. So to show this, we'll just check it with the first psi, and we see that when we take the inner product of the spin up of the first particle with psi, the resulting state that we get is we have to have the second particle in spin down state, which is the exact kind of anti-correlational behavior that we were expecting. And so if an observer first measures spin up in any direction, because we use the general spin up basis vector in either of the states on one of the particles, then another observer would measure spin down in the corresponding direction on the other particle. Therefore, the states exhibit the same correlations, and they would be indistinguishable observers. And this is kind of similar to how if we had, since the initial states are just minus of each other, we can kind of think about it in a linear algebra kind of way, so that if we change them both in the same way, we'll get the same vector out that also differs by a minus sign, and that minus sign would correspond to a relative phase, which we already said we can't measure, so effectively we get out the same state. And that's it.